this year, for the month of December 2023, I decided to publish a fun weekend project which would allow some of us at least a short escape back into our childhoods, and with a result that might be fun for some of your kids, and which would probably make also a fun little present for Christmas. So I imagined as a kid having a sort of a secret box where I could lock up some of the items that I liked and that I wanted to keep secret. Every kid has that wish to sometimes hide little items that they like very much in a sort of a secret box. And I thought, why not make a secret box which is also partially electronic? Yeah, so therefore making it fun to make for us and making it fun to use for kids, right? So I put together a little electronic circuit which you see down there on the breadboard to test it out, and it works rather well, and the goal is to miniaturize this little circuit to such extent that it can be built into that wooden box over there. Now obviously you don't have to choose the same type of box for your own project if you're going to copy my project, that is. I mean, you could use just as well a large cardboard box or a plastic box or whatever. The only caveat is that you can't use a metal box, at least not if it's not properly insulated against electrical currents, right? So I would advise using either a wooden box or a cardboard box or even plastic, right? No treasure box is complete without the special lighting effects, right? And our treasure box will have two lighting effects. One which is these blue LEDs which will light up either the top and the front of the box, I haven't decided yet, or just the top of the box. I'm going to decide as I go along. The green LEDs, instead of going on and off like the blue LEDs, they go on and off, but very gradually, very slowly, yeah. And I'm sure you can tell for yourself what I mean. So the green LEDs become brighter and brighter, and then they die away again. Last but not least, like I said, the box will be unlocked, so via this little solenoid here. Okay. Now the solenoid draws about 100 milliamps to pull in the little pin you see here, this pin here. Okay, so yeah, that requires quite a bit of power. Now one of the part of the circuitry which will let's say, command the little solenoid is right here. Okay, right here. You see this power transistor here? This will send the appropriate current through the solenoid. Why? Well, because unfortunately the CD 4017, which is here, so the chip you see here, is simply not able to source enough current to power a solenoid. Okay, it can source a few milliamps, let's say just enough to light up a small LED, which is, let's say, 10 milliamps, 15 milliamps maximum. Okay, so that it can power, but not more. Obviously, since the solenoid will draw at least 100 milliamps, you need a power transistor to power the solenoid, and which is exactly here. This is the power transistor which will power the solenoid. So obviously, like I said before, you want to power the whole circuit with a battery which lasts long enough. Okay, and you don't want the battery to run empty while you're not using the box, or, well, at least you don't want it to run empty too fast, yeah, while it is not in use. Okay, so I did a little bit of research to find a way to switch the whole circuitry off while it's not in use. And the way I do that is by using the lock as a switch. So the lock is metal, alright? So the moment you open the lock, yeah, you allow this power transistor here to conduct, and this power transistor sends power through the whole circuitry, all of the little sub-circuits and everything else, even the solenoid. Okay, so when, however, the lock is closed, yeah, this power transistor here is shut down, yeah, is shut off. When it's shut off, it uses a bit less than 1 milliamp. So the goal of the lock of the box is twofold. Well, obviously to keep the box locked even when there's no power going to it. Secondly, well, if you want to use the box without the electronic circuit, well, then later on you can. You can remove the electronic circuit or whatever and use it as a box. Okay, and also as switch. So if you open the lock, and the lock is built out of metal parts, so you have the upper and the lower part. If you open it up, obviously, because of the distance between them and because it's mounted on wood, the resistance goes to infinite, like thousands of megohms. Okay, so, and that allows that power transistor down there, so this one here, to conduct. Now, while the switch is closed, so in this position, yeah, the power draw will drop. Okay, So this is the power draw right now of the whole circuitry without powering the solenoid. Okay, so as you can see, it varies. The current draw varies, and that's because the LEDs light up in a gradual fashion, as it were. So if you take a look at the LEDs, you can tell that the LEDs vary in brightness. Alright, so obviously the brighter they shine, the more current they draw, and that's exactly what you see on the multimeter. Okay, so in their active state, so which is this, and so when the box's lock would be open but you're not doing anything, then the current draw would be around 15 milliamps. Alright, and that will stay like that even if you press the unlocking buttons. Yeah, so each time you press an unlocking button, you see the LEDs of the decade counter progressing. Even if you do that, the current draw will largely remain the same. So let me show you. So if I press the unlocking mechanism button, you see it's a little bit less than 15 milliamps. If however I don't do anything, it's a little bit more than 15 milliamps. Now obviously, like I said, when you arrive at the last LED of the counter, which will also action the solenoid, the current will jump up by quite a bit. The solenoid is not connected right now, but it would jump up to around about 110, 115 milliamps. Depending of course on the type of solenoid you use. You could actually make your own solenoid. I am just using a solenoid which is available commercially. Alright, the circuit has been transferred to the little perf board PCB you see over there. I haven't tested it yet, but before I start wiring it and testing it in earnest, I thought I would have a sort of a mock-up of what we want to do or how we want to mount it inside the treasure box, right? So I was thinking of mounting the PCB like this somewhere inside the box, right? So wait, let me zoom out a little. So I thought about mounting the little PCB somewhere here. Okay. Yeah, don't worry about the switch. I'll explain to you in a moment what that switch is for. But so yeah, I was thinking of mounting the PCB here, okay, or somewhere here, or maybe like this rather, okay, because I want to see how I need to put the wiring inside the box and a few other miscellanea, you know, like the LEDs and all such. There will be a small power connector mounted here to the side. There will be this battery probably mount it here somehow, like this. Okay, or maybe like this, I don't know yet. But I think either this way or that way. Okay, and I need to I need a few wires that go to the top of the lid, and well, at least for, let me see, 7 LEDs go to the top of the lid, and then 4 LEDs, so 1 to each corner of the box. So that would make 11 LEDs, 11 LEDs in total. And I also need to mount 6 switches, you know, switches like this. So press release buttons. Okay, so yeah, I need 6 of these and 11 LEDs, plus all the wiring for coding, as it were, the combination of the box, right? So yeah, at least now I have some sort of an idea how to wire it all up. Alright, I connected the whole print board up such that it mimics most or if not all of the connections it will make inside the box. And right away I can tell that the effects chip, so the 555 right here, is connected up correctly. So the LEDs light up the way it was engineered to do, you know. So the blue LEDs brightly on and off, the green LEDs go from bright to dim to bright again, just the way it was intended. The counter LEDs, so the red ones, do function as well, basically. So if I give a clock pulse, okay, you see that they light up in sequence, right? Well, almost all of them, but there is probably somewhere a bad contact, you know. I don't know yet if it's on the print board itself or if it's in one of the wires. I suspect one of the wires isn't connected correctly. The reset button though works perfectly. There. Okay, so there are in effect 2 quote-unquote errors I still need to solve. I need to solve one of the outputs. Actually, there are 3 things that I need to look at. One of the output LEDs of the counter does not light up, so there might be a problem with the connection there. 2, the on-off switch for the whole print board doesn't work. So with a closed loop like this, it should shut down, and it doesn't. So there is a problem there. And then the reset selector switch, which resets the board after a number of pulses, is working sort of, but not quite the way I expected it. Alright, I finally debugged the circuit and tweaked it to function normally, and I also tested the on-off switch, as it were. So it's a don't worry, I'll show you the schematic later in the video, but the point is the switch, quote unquote, is a transistor, which is either conducting completely, so they call it saturation mode, yeah, or if you short it to ground, so to speak, it cuts the power entirely. So if I simulate the switch like this, you see, all the LEDs are off. In fact, the whole circuit is off, right? So if I release the switch, then the transistor is powered again, and then the whole circuit starts to work. So this is the reset switch. Okay, and then if I press, let's say, the clock pulse button, as you can tell, the counter chip works perfectly as well. Alright. So, oh, and yes, I also made two other tweaks, which is I connected up the switch, which lets you choose between either 3 or 4 code positions. If you choose the 3 position code, then there are 2 resets in the whole circuit. Alright, so 2 buttons will be a reset, at least 2 buttons will be a reset, and 3 buttons will be necessary to key in the code, which can be any random permutation of the 3, right? If you choose the other position, you have 4 codes or 4 switches you need to press in certain order, and then there's another, at least one other button, which is a reset. Okay, so it's either a 4 code plus 1 reset, or a 3 code plus 2 resets. Alright, so you'll see what I mean by code and switches once the box is more or less finished. Okay. The other tweak I made was to add these 2 wires, which will ultimately feed the solenoid, which is this little thing here. Alright, so it's just a very simple linear solenoid, whereas here is the core. Okay, so there you go. So this is the solenoid. Okay, now as it was the circuit just didn't have enough oomph to make the solenoid close, so retract its pin here with enough force. You know, it was really wimpy, so I had to find a way to make it a bit more forceful, and I did that by adding a 1000 microfarad on the control transistor, yeah, which is this transistor over here, yeah, which is a BD139. Okay, so when the BD139 starts to conduct, in fact what it does is it then discharges into the solenoid. Alright, so in effect it increases the voltage which is sent through the solenoid, and therefore giving a more force to retract the pin. Okay, so okay, you won't be able to pull up an elephant with it, but it will be strong enough to unlock or conversely lock the box. Alright, so there's one last little mechanical detail that I need to fix, and that is that the solenoid came without a spring. Yeah, so normally the pin would sit out like this and would then be retracted like this. Now when it's unpowered, the pin should sit about this far out of the solenoid, and for that you need to have a spring at the back of the pin, right? And up to now I haven't found any spring which, let's say, which would give the desired result. Okay, so I still need to figure out what sort of pin I need or spring rather I need to use to make the solenoid function normally, right? So yeah, I'm not a mechanics expert, unfortunately, so it takes me a bit longer to figure that out. So now the circuit is finished. All I need to do is to drill a few openings in the box's lid and sides, right? Mainly for the LEDs, but also for the switches, you know, the code switches, and also the power supply. You know, the battery may run flat, and if there's no battery power, obviously you won't be able to open up the box. And to that effect I will mount a little power connector like this, which is a barrel connector, and I will mount it in the side of the box to power the circuit whenever the battery runs down, right? So, or you could also charge up the battery via the connector, of course. But that is only if you use a rechargeable battery, obviously. If you're going to use disposable batteries, then obviously you will be able to use this momentarily, so for a few seconds, just enough to key in the code and open up the box to replace the batteries, okay? But remember, you can't charge up disposable batteries, okay? That may cause fire if you leave them on a charger, okay? But for a few seconds it won't hurt. Alright, I used a very light pencil marks, okay, to draw out the position of, let's say, the main parts that I need to mount, or the holes that I need to drill. So my design calls for an opening here in the center of the top of the lid of 29 millimeters in diameter, and then around it a pentagram of 3 millimeter holes around it. The holes need to be completely, at least in my design, through the lid, okay? Then I also indicated the potential position of switches for pressing in the code, right? So there will be one at the top right, one in the middle down, or at the front of the lid, let's say, okay. And then I chose locations on either side of the box for other switches. You know, like there in the lower right corner, in the lower left corner. I also indicated which holes I need to drill for the power connector, and then there's another switch. And yeah, you might ask, but why are you changing the switch positions on either side, or on every side? Well, you know, this is supposed to be a treasure box, right? So treasure boxes are supposed to be, well, let's say mysterious, quote unquote, and not very easy to open, right? So it shouldn't be too logical, because that would make it really too easy. Remember, kids can be pretty smart. Okay, I also indicated the position of the let's say, I call them the creep factor LEDs, yeah? So very slow blinking green LEDs, okay? And there will be one on every side of the chest, yeah, the treasure chest. Also 3mm opening for an LED. So yeah, those openings I will need to make, although the switches will be mounted on top of the surface, not inside the surface. At least, you know, the switches I will use. But if you use different types of switches, then, you know, you'll have to adapt the design to your needs, right? The one thing that is crucial, though, is that, at least in my design, is that the latch halves, so the top half and the lower half, are conductive and metallic, yeah? Because remember, the latch is the on-off switch, right? Alright, so I drilled a hole, a center hole, through the lid of the treasure box, and I'm in the process of attaching all the LEDs and the buttons to the case. Now, doing that, of course, is not that easy. You need to drill a few holes here and there, and wherever possible I'm using press fit. So instead of gluing the LEDs, for example, I press fit them into the box, which makes it a bit more solid. Yeah. Next, what I'm doing is, right now, is making the circuit for the LEDs and buttons. And I'm using some very thin copper tape to do that. Okay, so this is 5mm wide copper tape, and yeah, well, as you can tell, I'm making a circuit with it. You don't actually need to use copper tape. You could do the same thing with wire. Sorry, just simple wire. But I have the tape, and I thought to myself, you know, why not? I mean, this is the perfect project to try it out. So there you go. That's what I'm doing right now. I did the lid already. What I need to do next is to do the lower part of the treasure box. Also, I rigged the lock, the box's lock, with contacts. As you can tell, yeah, I still need to finish a little bit. I soldered a little contact to the upper part of the lock, and I did the same thing to the lower part. Yeah, so I'm sticking it through the box's wall. Yeah, so I may have said this before, I'm going to use the box's lock as you could say the main switch. Yeah, it's taking me a while to solder the wires, and of course every time I solder the wires I need to test whether they work or not. I mean, I could forego testing them, but once they're mounted, the buttons, and then testing or correcting the wiring would be a nightmare. Testing the button or buttons is really nothing more than connecting them up to my multimeter, which is set on short circuit. Okay, so the multimeter will beep if there's contact when I close the switch, you know. See? Alright, I'm prepping the power connector for the electronic treasure box, and as you can see I'm using a barrel connector, and I connected a diode to the positive, so the center pin of the barrel connector, and the diode is connected to the center pin with its anode. Okay, and then I'm using a standard connector which they use in combination with lipo batteries, you know, so lithium ion batteries. So this kind of connector. Okay, so this is female, the one you see there is male, and you can buy them separate. So you can buy the pins separate, and you can buy the connector housing separate, and you can make your own connector, and that's exactly what I'm doing. So one end of the barrel connector will go to the battery directly, the other end will go to the circuit of the encoder, right? So that way you can either charge up the battery, and or if the battery is totally empty, power the circuit and still use it, but then with a charger. Alright, so there you go. Alright, we're nearly done. So what I need to do now is mount the solenoid to unlock the box somewhere inside, and when the solenoid is mounted and tested, then I need to finish the last few let's say aesthetic details of the box, and then it's done. Then we're finally done. This is the schematic of the electronic treasure box, right? Don't worry, you'll get the parts list further on in the video, but I just want to give a few tips if you want to build it for yourself. My first tip is that on this schematic I divided the circuit in three parts. So you have this part here on the left, which is a coding circuit. This part on the right, which is the lights effect part of the circuit for the blue and the green LEDs on the treasure box, and then this final part here, which is the main, you could say, power switch, which powers on and off the whole circuit. Alright, you don't have to use all three. You can use either one to your heart's content, but I would advise, if you want to make your battery last longer, to use the main switch circuit, which I depict here. Okay, if you use this little circuit and you use, say, the latch or the lock of whatever treasure box you're building to switch it on, when the circuit is, you could say, in the on state, the whole circuit only uses about 600 microamp. Okay, so 600 microamp is like 0.6 milliamps. So your battery will last way much longer if you use this little circuit here. If you don't, you can build your own sort of switch, which would switch the whole thing on or off. And in that case, of course, if you just cut the power from the battery, then your battery will last as long as the battery lasts, right? So yeah, that's my tip. You can use either circuit or all of them, but I would use this little circuit with the other two. But that's only my advice. Okay, the next advice I would give is the values of RA, RB, and CB are free to choose. Depending on the values you use, you can make the LEDs flash either slowly or quickly, right? Now, I would advise using for RA and RB 43 kilo ohms, and for CB 47 microfarad. That gives the right, let's say, slow blinking that you would expect from the LEDs. Now, if you want to speed the blinking up, obviously you could use either smaller resistors or a smaller capacitor, or conversely, if you want to make it blink slowlier, you can either raise the value of the resistors or raise the value of the capacitor. It's up to you. The way I designed it is to power 3mm LEDs, blue and green. Now, mind you, the blue, especially the blue LEDs, ask a slightly higher voltage than the green ones to light up brightly. Okay, so keep that in mind. Blue LEDs on average demand quite a bit more electricity than other colors to burn brightly. Okay, so there you go. The values that you'll find on the other list, so on the parts list, are all the values that I either calculated or experimentally found out. They are all suggested values. You don't need to follow the values that I suggest on the parts list, But if you use the parts that I suggest, you will get, let's say, the best type of working out of the circuit. Okay, so there you go. Those are my suggestions and my advice. Yeah, now it's up to you to build it and make it work. One more thing though, if you're going to use a latch mechanism the way that I built it with a small linear solenoid, um, do choose a solenoid which demands low voltage and low amperage to work. Okay, obviously the one that I bought was, I hate to admit it, a little bit on the weak side. Okay, now where would you buy all the components for the circuit? Well, I usually buy them on eBay because it's more convenient for me. But you can buy the parts on Amazon, on AliExpress. I think you can even get them on Craigslist. So, yeah, you can even go directly to an electronics sales company, you know, like Mauser Electronics or stuff like that. Um, the parts are not really very critical, and I think if you shop around, I think you can get away with spending, say, let's say $15 for all the components. Yeah, if you use a few extra things, you know, like IC sockets or copper tape or stuff like that, or special switchers, uh, you might bump up your, let's say, budget up to $20. Okay, but I think with $20 for everything, so even connectors and sockets and you name it, even wiring and solder, I think with $20 you'll manage to build the whole circuit. Alright, so this is the parts list for building the circuit. Now, I just want to give you a few tips, okay? So, to build the circuit, I used a few extra components which are not mentioned on the parts list. So I use IC sockets for the ICs, and I also use copper tape to make the circuit, and some cheap low power wiring to make all the necessary wiring. I also use two switches for the circuit, and one of them is this uh, double pole double throw switch. Okay, so like this. I think this little switch costs $1.50, I think, but or maybe even $2. But if you buy them, say 10 at a time, you can get them cheaper. Okay, so that's one type of switch that I use in the circuit. Then the other type of switch I use, namely for keying in the code of the treasure box, is this kind of push button. Okay, so it has only a single action, which is to when you push it, you make a circuit. When you release it, it breaks the circuit. Okay, so it's just a simple little push button which is meant to be soldered onto a PCB. Okay, These are, depending on the quality of course, relatively cheap. I think you can get them for $1 a piece, but I think it's cheaper if you buy them, say, 10 at a time or 20 at a time. Then you can get as low as uh, 20 cents per switch if you buy them by the dozen, let's say. Alright, so those are the tips that I can give you when you do some sourcing of the parts you need for building the circuit. Do be aware that the choice of the solenoid, which I depicted there, yeah, is critical. That is, if you're going to build it the way I built it, um, do look around for a solenoid which uses low voltage, so let's say 5 volts or even lower if possible, and little current. Okay, so don't exceed the 100 milliamp current for a solenoid, because if you do, it'll work, but your battery will run low in after only a few times using the circuits. Okay, a solenoid is pretty hungry where current is concerned. Alright, we're nearly there. So the only thing I need to do is mount the solenoid to unlock the box and then test it out, and when that is done, then I just need to finish a few aesthetic jobs on the box to make it look finished somewhat, and there you are. The electronic treasure box will be finished. Alright, I found the right spring. Actually, I made a spring for the solenoid and it seems to work sufficiently well to do what it needs to do. You know, so I need a displacement of about, say, 3 or 4 millimeter, not much more. So let's simulate how it works when I power it, right? So it does exactly what it needs to do. It moves 3 or 4 millimeter and then it springs back to its original position. Now the next thing I need to make is a latch, and I'm going to use copper wire like this, which I shaped like a U, okay, and which will fit in the box, in the lid of the box, and when the lid is closed the U will sit about like this. Alright, and just in the right position so the latch can spring back and release this so that the box's lid can be opened. Right? So it will take a little bit of finesse to make it work, but I think I can make it work without too much trouble. Now the solenoid as it was originally didn't function very well, and it turns out that for some reason the producers of the solenoid had built in a little pin like this at the bottom of the race wherein the plunger moves, right? So this sat at the very bottom of the solenoid, and I don't know what their intention was with this pin, let's say, but either way this pin took away a lot of the magnetic field which would actually retract the plunger, and also it gave the plunger much less travel. So I drilled it out. It was crimped to the bottom of the solenoid, and with a little drill of my Dremel tool I managed to drill it out, and now the solenoid seems to work perfectly. Alright, now comes the hardest part of all. I mounted the latch to the lid of the treasure box. I in fact used a little bit of epoxy glue to glue it to the top of the lid. Let me show you a close-up. There, you see? That's how I glued it to the top of the lid. And now I need to make the latch, which I gave a slight angle, as you can tell. Alright, I need to form it such that it drops over the little plunger of the solenoid you see down there. I'm pointing at it with my thumb, right? So of course I measured everything, so I knew, give or take a few millimeter, I knew where the plunger end would be. So, and in function of that, of course, I glued the latch to the top of the lid. Now, the problem is you need to make the latch fit exactly right over the very top of the plunger, okay? And obviously when you close the box, that is very hard to do, since you can't look through the wood. I don't have X-ray vision for sure. So there is a trick, of course, and the trick is to attach a very thin little cord. In fact, I'm using nylon wire, which I think you can barely see it, but I attached it to the latch, and it allows me to pull in either direction when I close the lid. The wire is so thin, in fact, that when the lid is closed, it slides easily back and forth. Okay, so what I'm going to do is I'm going to close the box, and then I'm going to try to eyeball it first by keeping a slit open, yeah, and looking into the box with a flashlight. Excuse me. And when I think I'm very close to making the latch fit over the plunger, then I'll close the box completely, and then I'll give very little nudges to the little wire to form the latch to the right shape, yeah. And then of course I'll use the code to open up the box, and that will be the ultimate test whether I did a good job or not. So give me a moment to do this, and then I'll get back to you once I'm finished. Alright, to prime the box, all you need to do really is to unlatch it. Okay, I'm using the latch as the on-off switch. There you go. As you can tell, the centerpiece here is lit. by blue LED, and of course there's also the green LEDs on the side of the box, which flash at a slower rate than the blue LEDs. Okay, these ones in fact. So yes, the latch is the main switch, quote unquote, which switches on the whole box. Now, excuse me, around the centerpiece there are these 5 red LEDs, and these are the code indicator LEDs, right? None of them are lit, but as the sticker right next to this button here indicates, you can start keying in the code if you press this button first. I thought, you know, well, why not give the kid a little clue where to begin, right? So I press the button, and you see now the code lock is primed. So the whole thing of the treasure box is that you need to key in the right sequence the buttons which are spread all over the box. Okay, so there's a button at the back, one at the top, there's one on the side here, there's another at the front, and then there's another on the other side. Okay, so there are 5 buttons in all to press. So normally, like I said, if the mechanical part of the latch would have worked properly, you wouldn't be able to open up the box. Alright, so as it is now, it barely gets some resistance from the latch. Okay, but yeah, like I said, that's the one part that really stumped me, the mechanical part. Anyway, now that the code sequence is primed, as it were, yeah, or armed, you need to press the buttons in the right sequence to open it up. So if you press the right button first, so you saw it jump one position, yeah, but then you go out of sequence, nothing happens. Yeah. In fact, if you press the key button again, you reset it. Yeah. Obviously, that is something that I wouldn't divulge to the kid who's trying to open the box. It's something that they need to figure out for themselves, right? So, the point is, you need to key in the code in the right sequence. Now, of course, I built the box, so I know the right sequence. Okay, so I'm going to show you what happens if you press the right buttons in the right sequence. So you start by this button here, then you go to the back, then you go to the side, and then you go to the other side. And at this stage, the latch should unlock the box, which it does, but barely. Okay, so like I said, the mechanism isn't perfect. So there you go. And then either you reset the whole thing by pressing this button, and then the latch would close again, and then that would technically close up the box again. So you would have to key in the right code again. So 1, 2, 3, 4, and then you could open the box, and then this is what you would see inside the box. Alright, so like I said, this is still a prototype. Okay, I just wanted to see, as a proof of concept, whether I could make it work or not. And well, like I said, I will need to spend some time on finding a mechanical solution to the latch mechanism. Alright, so that little mechanism you see down there. Yeah. It's not perfect, I'll admit it. But yeah, I need to think it over how to find the right solution for it. And I ran out of time. You know, I need to head this video out on my channel. So there, if you feel called to suggest a solution, or maybe find a solution which would work better than mine, then please do so in the comments below the video. So there you go. This is how it looks on the inside. If you're going to build something like this yourself, you could hide the electronic part, but you know, I thought maybe boys would like to see what powers the lock, right? But then again, if you pick a larger box, let's say, you could hide the electronics completely and the wiring as well. Maybe you will think that is more aesthetical to do so. Either way, if I think about myself as a kid back in the day, I would have loved to see the electronics, you know. Even though I may not have understood back then what it did exactly, I still would have loved to see it, right? And to see the effect the electronics has. Yeah. So yeah, there you go, the electronic treasure box. But you'll need to figure out for yourselves how to make the latch, one, powerful enough, and two, foolproof enough to make it function correctly. Okay, like I said, I'm not a mechanics expert. So there you go, the electronic treasure box. Yeah. And then when you want to switch it off, you just close the latch like this. Okay, there you go. Okay. By the way, these stickers that I bought are glow in the dark, so which adds a little bit of, you could say, fun creepiness to the box. But you know, I'm sure there are some people out there who are far better at designing a quote-unquote treasure box than I am, right? But I had my share of fun making it and designing it and prototyping it. But like I said, I started to run out of time, and I really wanted to have it out there on my channel. So there you go. I would want to give you a few more tips, and just let me open up the box again, and then I'll give you a few tips. Alright, so when you're going to build this, don't worry, I'll put the schematics in the video, so you'll be able to analyze the circuit to your heart's content. But I'm telling you already, so I made a conscious choice to only use 5 push buttons to key in a code, okay? Because I could have made it devilishly complicated by using up to 10 switches, which is in theory what the IC I'm using could handle. Yeah, the IC could handle up to 10 switches. But as it is, with the 4 switches and a reset trap button or booby trap, there are some 120 combinations possible. Yeah? By changing the sequence of the buttons, you can change the code to your heart's content. Okay, if you use, instead of 4 plus a reset, you would use 5 plus a reset, you would have 720 combinations, etc., etc. It exponentially goes up the more buttons you use. In fact, I think the correct term is not combination, but permutation. Okay? So yes, you could go theoretically up into the hundreds of thousands of possible sequences to open up the box, provided you use more switches. Now, you'll notice that there are these copper traces here. I decided from the onset not to use simple wire to make the circuitry, but to use copper tape traces. Okay, it's far easier to do, in my opinion, and it allows you to make circuitry which follows the contours of the box you're going to use, or any object really. Yeah, suppose you would want to make say an electronic treasure garden gnome. Yeah, you could stick the copper tape on the inside of the gnome and have it follow the contours of the doll inside without any sort of problem, which would be much harder to do with just regular wire. Okay, now mind you, this copper tape is very thin, so it's not built to conduct a lot of current. Okay, for powering a few LEDs it's just fine, but don't use this to power a heavy motor or something like that. That won't work. Okay, so then you might wonder, okay, you said, oh, change the sequence of the buttons. How do you do that? Well, it's quite simple. If you look at the inside of the front of the box, you can see down there copper traces. Okay, let me give you a close-up. There. So there. So these copper traces form like a sort of a matrix, you could say. So you have for each button a copper trace, yeah, and then you have a common trace for all the buttons who key in the code, and you have a separate trace for all the buttons who key in a reset. So remember, it's not just keying in the code which is important, but it's also the booby trap switches which are important. So for this model I only built one booby trapped quote-unquote button which resets the sequence if you press it. Okay, it just happens to be the button at the front, indicated with the key sticker. So by attaching or by soldering the little wires from the switch to the right track, yeah, you can change the combination. So I used one particular combination. You could make your own. by changing the sequence of the buttons. Yeah, so every line in fact gets a signal from the counter chip you see here. Okay, so this is a counter chip here. Okay, and the counter chip sends a signal to the decoder LEDs in a sequence. Okay, and the real trick, or the real let's say secret of the solution, is that every positive pulse that comes from one of the outputs of the chip, yeah, is routed to one of those copper traces you saw on the inside here of the box, right? And then all you need to do is connect any switch that you like to use to the right trace which is powered. So you would need to find the trace which is powered by this output of the chip. Okay, and then if you press the right button, you see it moves to the next trace. So then you would need to connect the next button to the right trace, which is powered now by this output of the chip. Yeah, and etc, etc. So you move on, and every next trace is powered by the chip, and you need to find the right strip then to connect the right button to. Okay, so in my design you need to press four buttons in the right sequence. If I press them out of sequence, which I will demonstrate. Okay, so now I normally should press the fourth button. Okay, but let's say I press the very first one. You see, nothing happens. Neither when I press the second one or the third one. Ah, there it goes. Okay, and then we press the last one, and now the latch unlatches. Okay, and then this is the reset. Alright, so again, 1, 2, 3, 4, unlatch, and then reset. If the last LED or the last output of the chip is reached, the latch normally, which is down there, yeah, would unlatch. You would hear a click, and then you would be able to open up the box. Okay, but like I said, my mechanical skills aren't that good, so I haven't found a really perfectly working solution for the latch. The latch is powered, by the way, by a power transistor, so it can deliver enough current to power, let's say, a solenoid, even a little motor, or maybe, I don't know, a relay or something like that. Okay, don't go over the top. Okay, so it delivers around about 7 to 9 volts at maximum 1 amp. Okay, so as long as the battery lasts, this can power up to, I think the limit is 30 volts and 1 amp with a heatsink. Without a heatsink, forget it. All you can power then is about, I'd say 9 volts and maybe 200 milliamps, and that's it. If you go higher than that without heatsink, the power transistor will blow up. Okay, quite literally actually. So there you go. Oh yeah, I use for this design I use a lithium battery, which you can see right here under the mechanism. Yeah, I'm using the mechanism as a battery holder. Okay, so that way the battery can't fall out or anything. And yeah, and in my opinion, a lithium battery is perfect to power this sort of thing. But nothing stops you from using, say, a couple of 9-volt batteries in parallel, yeah, to give you enough power for the solenoid and everything, or to connect up a power supply. So remember, if the battery runs flat, so has no more power left to open the latch, then you're stranded, right? So then you wouldn't be able to open the box anymore. So I needed to find a way to still give you access to the box even when the battery ran flat. And that is what this connector here does. Okay, so it gives you the opportunity or the possibility to power the box externally via a power supply to open it up, and even to charge up the battery if that was your intention. One last warning. This is a lithium battery. Don't overcharge it, don't overheat it, and don't puncture lithium batteries, okay? There is a fire hazard there. Yeah, lithium batteries are finicky things. So always use the proper charger, never short circuit the battery, and never puncture them, or break them, or cut them, or whatever, okay? If you don't want this kind of quote-unquote risk, then use disposable batteries, and that way you won't have that sort of problem. So there you go. The electronic treasure box project is at an end. Next month, with a bit of luck, I will publish a new project. I mean, a new restoration. More than likely. I'm not sure about a live cast in January, because I'm a bit tired. I really need a bit of rest. Okay, so I'm going to take a short break during the holidays to recover some of my energy, and I'm sure some of you will do the same thing. But so there you are. The only thing I need to tell you now is I'm wishing you all a Merry Christmas, at least to those who celebrate Christmas, and a happy, successful, fun New Year, and a prosperous 2024 for all of you. And thank you again for visiting my channel, for subscribing to my channel, for giving me all those nice comments. I really, really appreciate it. So again, thanks for watching. A happy New Year and a successful 2024 to you all. Thanks for watching.